Good afternoon. Thank you for standing by. This is Michelle Giroux of the Rural Wireless Association. The RWA Education Committee is pleased to welcome you to this RWA webinar on transitioning your 3.65 license to the new 3.5 band. I have a few quick items to cover before our presenters get started. During the presentation, all participants will be in listen-only mode. We encourage you to type your questions into the chat box throughout the presentation, and our presenters will answer questions at the end of the webinar. If you know which presenter you would like to answer your question, please type his name with your question. The chat feature is located in the lower left-hand corner of your screen. If you need to reach an operator at any time, you may press *0. Finally, this conference is being recorded July 27, 2017, and will be available on the RWA website. I would now like to turn the conference over to Bob Silverman of Bennett & Bennett.
Hi, everyone. Sorry, I still had it on mute for a second. Thank you very much, Michelle. I'm going to just basically be giving a broad regulatory overview of the 3.5 gigahertz band and the Citizens Broadband Radio Service, and also how that will have an impact on 3.65 gigahertz licensees. Many RWA members hold this spectrum and are currently working to get it transitioned into the 3.5 band. So rewinding a few years, several years actually, as part of the FCC's, let me go to the slide. As part of the FCC's efforts to unleash spectrum, they initiated a rulemaking back in 2012 to commercialize this wide swath of government spectrum. And after a lengthy rulemaking process, finally adopted some rules in 2015 in an April 2015 3.5 gigahertz order. The FCC established this band, the CBRS, as a quote-unquote innovation band for commercial wireless broadband uses. And they decided at the time to adopt a regulatory framework that would make it hospitable to a wide variety of users, deployment models, and business cases, including some solutions to market that are not adequately served by the FCC's conventional license or unlicensed rules. As I mentioned, this is a 150 megahertz swath of band from 3550 to 3700 megahertz. And obviously that includes the 3650 to 3700 megahertz band, or 3.65 users that have been in operation since about 2007. The FCC's rules were generally designed primarily to protect incumbent federal uses, also really to promote flexible wireless broadband uses, so different fixed and wireless applications and industrial applications. And it's so important to note that during the course of this rulemaking process, there was a significant reconsideration phase where several parties asked the FCC to reconsider various portions of the rules, and the FCC did that. During the reconsideration phase, the FCC did tweak some of its rules, adding things like spectrum leasing. But for the most part, they largely affirmed the license framework. So that framework, as it exists right now, is again primarily it's a top tier, which is always protected, are the federal applications, the federal uses, and for radar and satellite. But then the next tier of protection is the priority access licenses, or PALs for short. These PALs will be auctioned off in 10 megahertz licenses with a limit of census tracts. So census tracts are currently the geographic license area for these. And in a compromise, the FCC decided to adopt 3-year terms. These are actually three-year non-renewable terms, except for the very first term. In the initial PAL auctions, they will allow applicants to seek 2 consecutive 3-year terms. Then the class with the least amount of protection, but has almost the greatest amount of flexibility, is the General Authorized Access Tier, or GAA. And that will operate on a sort of license-light basis, with users essentially registering with the SAS or spectrum access system that I'm going to discuss in just a second. This is a visual representation of the 3-tier classes, 3-tier license system. And it's also important to note that the FCC's rules did provide 2 classes of base stations, what they call Class A and Class B. Class A being the low power indoor base stations, primarily and for small cells. And then Class B is the higher power base stations for outdoor use. And both either PAL or GAA licenses. So as I mentioned earlier, the magic that will make all of this spectrum sharing happen and protection of incumbent users is the SAS, or Spectrum Access System. Conceptually, this is similar to the TV White Spaces database. And the SAS will use dynamic frequency coordination to maximize users in an area, while at the same time enforcing the various protections among the different tiers, including that includes power limits. And that SAS will work in conjunction with an ESC, or an environmental sensing capability operator, and that is a component that interfaces primarily with the incumbent users to offer the most protection, and that will talk to the SAS, and the SAS will do the coordination. Last year, the FCC initiated a first wave application process for parties to become a SAS administrator, and several were conditionally approved. Those are listed here in the slide. And then a second wave earlier this year drew some more proposals. So that is still underway and is still in the testing phase. So an important part of the adoption of this band is what is being done with existing users in the 3.65 band. The 2015 order did adopt a transition period for 3.65 users. At the time, it was a 5-year transition. Of course, we're a few years into it. Basically, in which incumbent 3.65 users can continue to operate no later than April 17th, 2020. That's 5 years from that initial order. So you can continue to operate. You can renew your license, but the latest renewal can be, it will cut off at April 17, 2020. And then after that point, you have to adapt to the CBRS band. Now, to support this position, the FCC adopted grandfathered wireless protection zones so that 3.65 users can have continuity of service. In order to be granted a grandfathered wireless protection zone, you have to have, with your license, registered your sites by the April 17, 2015 date. That was the date of the 3.5 order. And it will have to have been constructed a year after that, so April 17, 2016. The FCC developed a 2-prong approach for establishing these protection zones, depending on whether you have unregistered or registered CPE, and some of the details are spelled out in the slide. But what is the most important thing to remember now is that to establish this protection zone, you'll have had to have done a separate filing to make various certifications and register certain information with FCC on using their online filing system by August 7th, 2017. So that's coming up very, very soon. And in order to get that protection zone by that August 7th deadline, you have to meet 4 separate requirements that are spelled out here. This filing is supposed to be intended to be pretty straightforward and should be automatically accepted as long as you satisfy those 4 requirements. One note of caution here is that 3.65 users need to be careful of any modifications they've made to their registered sites, because that can have an impact on your grandfathered status. And I should also note that once these zones are sort of locked in, that does not mean users can no longer register new sites. It's just that those new sites won't be offered grandfathered protection. Now, one reason for noting the importance of the current CBRS framework is that just last month, several Tier 1 wireless carriers, mobile wireless carriers, so it's T-Mobile and CTIA, filed petitions for rulemaking that are proposing to retool the CBRS license framework and also modify various other rules, including some technical rules, that essentially would shift the licenses more towards the traditional mobile wireless model. For example, they're proposed census tracts to go towards partial economic areas, or Ps. These were larger license areas developed for the 600 megahertz auction that was just concluded earlier this year. They also want to go from 3 terms to 10-year terms. That probably sounds familiar. Most spectrum is licensed on a 10-year basis, but for mobile wireless use. And also would like to see all 150 megahertz, and that's actually T-Mobile specifically, all 150 megahertz used for PAL with some opportunistic GAA use for, I guess, the unclaimed spectrum that is not auctioned off. And of course, to go with it, the petitioners propose higher out-of-band emissions and power limits, and this is really geared towards 5G applications for mobile wireless. And just this week, we saw a groundswell of commenters who came out largely to oppose these major license changes, proposed license changes, because the writing on the wall is pretty clear in that if those changes are enacted, the spectrum is going to become much more expensive and pretty inaccessible to small and rural providers. Of course, this is not representing all of the issues that were presented, and there's a variety of positions taken on those others. But if you do wish to review those comments, I encourage you to do so. And if you wish to participate, there's a reply comment deadline coming up on August 8th, 2017. And the FCC will really need to act fast, because this already causing a lot of delay and uncertainty in what is happening with this band. So currently, where we're at is that, as I mentioned earlier, the SAS authorizations are still underway. They're in the testing phase at the FCC. At the same time, the FCC is awarding some special temporary authorities and experimental licenses to various CBRS stakeholders who, for the most part right now, are investing resources towards continued service and growth of that service, very much relying on the existing license framework that was established years ago. So various trade groups that are in this space, including the Wireless Innovation Forum, or WIN Forum, are working on developing standards, and other groups such as the CBRS Alliance are trying to promote various technology solutions. In their case, it's LTE-based solutions. On the next slide, I'm not going to get into these, are some of the sample applications that they've mentioned in a recent white paper, and the link is provided in the slides. And the various technologies and applications that are evolving, this is, I'm going to hand this over next to T3 Broadband, and they're going to discuss more of these applications.
Okay, great. Yeah, thank you, Bob. My name is Dave Kirk. I'm with T3 Broadband. Many of you know us as T3 Wireless. However, we have changed our name recently because we have added quite a few landline-type services. But we are very passionate and believe that broadband is a lifeline for rural America to communicate to the rest of the world, for business and schools and hospitals and everything that has to do with keeping in touch, and we've been very honored over the last 15 years or so collectively to be able to work with our customers to provide good quality broadband. So we're probably best described as a full service independent system integrator for major wireless equipment manufacturers, and it is important to understand that we're objective to different technologies and manufacturers. We basically get up every day to try to cater to the needs of both the rural telephone community and the public utility market. So we're constantly evaluating different technologies and equipment and manufacturers and processes to try to better serve our customers. Again, I'm very happy to be here to talk about fixed wireless. It's been a big category for us for a long time. It's something that we've been working on really for about 15 years. And when 365 was introduced a few years back, it was much needed spectrum to add to the unlicensed bands. And it's been very highly successful, in our opinion, for fixed broadband wireless. And as evident, there's over 3,000 FCC registered networks out there today covering the initial 365 50 megahertz that are available. And as Bob alluded to, this is lightly licensed, meaning you must register those locations and the details of the deployment. But one of the things that's made it significantly different is there's not non-traditional network devices out there that we fight sometimes in the unlicensed world, baby monitors, SCADA systems, things like that. The band has done a lot of the heavy lifting for fixed wireless over the last 6 or 7 years. Historically, proprietary hardware and WiMAX has accounted for most of the telco-grade deployments up until about a year ago. And the consumer-driven bandwidth requirements, along with funding associated with the minimum speed requirements, such as CAF and ACAM, has really fast-tracked the need to move technology and the need for speed and using potential larger channels and that are capable of delivering the higher consumer needed speeds. So traditionally, fixed wireless and 365 networks have been pretty small with very few, really over 5,000 subscribers. But for the first time, we really see that changing, and Tier 1, Tier 2, and Tier 3 operators are looking to deploy fixed wireless on a much larger scale and very strategic to what they're trying to do in their specific trade areas. And again, this is very much due to the technology advancing, faster speeds, more reliability, and the business case itself just looking better. And that cost-effective business case has evolved using really a hybrid approach, using a mix of unlicensed spectrum and fiber and all kinds of mediums to serve both the rural and metropolitan areas. So for CBRS, a big discussion and is this better for fixed, or is it better for mobility, or better for both? And there's a few technical, physical things that I think immediately categorize best uses for CBRS moving forward, at least in regard to the proposed ordinance that's in effect right now. But power is a big issue for fixed wireless. So the device power limit categories are a big category here, and right now the proposed ordinance shows basically on the device side, which is always your weakest link in any type of a wireless network, two basic categories. And there's a lower power category to 30 dBm that's designed for fixed location, indoor and outdoor. Again, that's very low power for in regards to mobile cellular type network. And then the Category B devices, they have raised the power up to 47 dBm. Again, it's for fixed location, outdoor use only. There's some definite technical things that need to be associated with those FCC-approved devices. And then there's kind of a subcategory. I'm not exactly sure why that isn't Category 3, but there's a subcategory for mobility-type devices that are extremely low power to 23 dBm. So just those power restrictions in itself really lend this CBRS band for fixed wireless, with the exception of a few specific type of maybe some indoor use, some specific indoor type mobility applications in regards to how it might evolve to 5G. As Bob alluded to earlier, I do think it's important to watch these power limit categories and what happens in the rulemaking, because especially with what's come out here as of late, the Tier 1s continue to lobby to the FCC for more power and larger license areas to accommodate options for mobility and the current cellular offload. And the cellular industry is definitely needing more spectrum, and they see this as an opportunity for a road to 5G and to offload additional broadband. But there's no question, should they go to larger power or larger license areas and larger power requirements, that will have a major impact on the smaller operators and their ability to technically function and compete if that should happen. So surveying the landscape and looking forward to, if you're a new operator, if you're an operator today and looking to try to decide how do I get into or how do I transition my existing networks and take advantage of CBRS, assuming whether you get spectrum or you don't. There's some key rules we believe that you need to pay attention to and watch and operate by moving forward. And again, I just alluded to the power issue. 3.5 gigahertz is primarily a line of sight frequency. So again, at the lower proposed power restrictions and the different tiers of priority there, these are being challenged by the larger operators. But again, you really need to make your plans specifically around fixed wireless. Adjacent interference is an in-depth topic, but just to touch on it briefly, with the power going up with the new CBRS rules to 47 dBm in some areas, that's going to create a potentially very crowded RF environment with as many as, worst case scenario, 10 megahertz channels being run side by side. And it will require a really quality hardware solution to be able to survive in that type of an RF environment. And so that potential adjacent interference, even with the SAS requirements, is a threat here. So you have to really do your homework, I believe, in looking at what type of equipment you use and pick out to be able to successfully manage that and have a good customer experience. The channel size, we all are, constantly being told about the speeds and feeds of a lot of the different types of equipment that's out there. But one of the things that most manufacturers have done to get to the higher bandwidth is increase that channel size. So in the engineering process, that's going to be very important to understand what channel size you can successfully run, again, in what potentially might be a crowded environment. And of course, the SAS server, your equipment must be able to detect and avoid the existing federal deployments out there and be able to minimize your interference with neighbors. So for us, again, surveying the landscape, I think a hybrid approach in many cases is still in order, where you're going to be using multiple frequencies for fixed wireless and maybe even matching with the different mediums to serve your trade area. And that's the best way to minimize your risk and also maximize your capacity. So from a technology standpoint, it really comes down pretty quick to a couple of primary options based on what we know today for CBRS. And certainly the debate will go on, but there's two primary technologies. Certainly LTE, in this particular case we call it GAA LTE, or what we have recently called unlicensed LTE. LTE has just been a fantastic technology. It's obviously growing, very successful as a mobile technology, and it's a global standard. So technically it has great interference mitigation, and the idea of potentially entering into that lower cost ecosystem is certainly attractive. Some of the cons with LTE is there are quite a few hidden costs, and it is a more technical solution that requires additional expenses of a core or some form of a core or EPC. It generally requires advanced complexity on the human resource side and the skill sets to be able to continue to manage it and support it. In some cases, there's actually even less bandwidth with LTE, depending on channel sizes and whatnot. And probably the hardest to understand and track and follow are the challenges for interoperability in the IoT scenario, which is, again, LTE, we think of an open standard, but in essence, it's still building an island at the for fixed wireless, unless you have entered into one of the bigger manufacturer realms. There just isn't a lot of interoperability right now with the smaller LTE manufacturers. So there isn't a strong current roadmap to mobility, and the power limitations certainly make a case against some of the LTE advantages. So I would say we all have to ask ourselves again, will history repeat itself like it did with macro licensed LTE for the big cellular companies and the cellcos? And there potentially was some false hopes there of roaming capabilities due to some tier one positioning and some of the politics associated with that, again, getting into the interoperability issues. And then the handset testing requirements from some of the major device manufacturers. A lot of people haven't got into that phase of it yet, but if you're going to actually sell those types of handsets or try to get into the business, there's quite a bit that has to happen just to certify your network to be able to use those types of devices. So the other primary option that we see for CBRS would be back to the proprietary fixed type solutions. And some of the pros of that, for what we know today, it provides the best business case just due to the simplicity of most of the products that are available out there and the deployment and the management of those products. It doesn't take a core. It's the quickest go-to-market due to that easy deployment and cost. And there are extremely high bandwidth options today, and for bundling services such as triple play, and those types of things obviously create revenue and a high customer satisfaction. The cons or perils of going to a proprietary type solution is that not all products are created equal. So there is not an interoperability path or standards based on a roadmap. So you, in essence, are building somewhat of an isolated island of sorts in your network. And you really need to be aware of technically poor options that aren't capable of coexisting in this new challenging RF environment that's been outlined, even with the SAS servers. So, and also they need to obviously have a roadmap and be compliant with the CBRS. That's about all I have today. So again, I appreciate the time here, and certainly if there's more questions, we'd love to field them or follow up afterwards. So with that, I'm going to turn it over to our next presenter, Edon with Radwin.
Okay, thank you, Dave. In this presentation, I'll go over some of the more technical details of the CBRS and what it means as far as products. Let me start with a quick introduction of Radwin. We are an equipment manufacturer. We manufacture a carrier-class wireless broadband equipment. This equipment to be used by service providers that are especially focused in SLA delivery, delivering services high quality with high capacity. As a lot of you know, we have products that are point-to-multipoint, point-to-point, and some other mobility solutions. Our flagship product is our beamforming technology that is used to point-to-multipoint applications. Some of the technology that we focus on enable to deliver high-end high-end services, especially with high capacity, while working under extreme conditions of interference, while still delivering the capacity that meets or exceeds the customer requirements. We are deployed in more than 160 countries, and we have more than 19 worldwide offices spread all over the globe. Our headquarters is in Tel Aviv, Israel. Now, as we all know, over the last decade, there is a significant uptick in overall internet data consumption. All the data services are significantly increasing year by year. However, one specific application sticks out, and this is the video. Video over IP is an application that, as you can see from the two charts, is just exploding. A lot of services, whether those are unicast type of services, over-the-top services such as Hulu and Netflix, or other broadcast type of services, are being heavily used by end users. We are seeing more and more houses, they have 2, 3, 4, or even more TVs that are open simultaneously and tuned to see some type of video over IP, IPTV type of services. And as you know, the bandwidth requirement, as the quality of the picture goes up, the bandwidth requirement comes up significantly. So the end result of this significant increase in overall data consumption, combined with a significant increase in usage of IPTV type of services, is a significant increase in usage and demand for data services. What does it mean for our end customers? You would expect with this type of demand that a lot of the customers are already covered with good infrastructure to deliver the needed capacity in order to get those type of services. However, this is not the case. Even today, in 2017, in many rural areas, there is extremely poor service, and customers are unable to get their services because of infrastructure. If you look at the typical service, a service that is needed in order to get a good quality of data and video, 25 downlink, 3 megabit uplink, 23 million people in rural areas are not able to get good service. And this is large amount of subscribers. And this is just, as I said before, this is today. This is the coverage that is available today. If you look at the lower tier type of service, 4 megabit downlink and 1 megabit uplink, 12 million people are unable to get decent coverage with those type of parameters, especially in rural area. So the bottom line is, although there is a great deal of demand, there is still a real difficulty to deliver those type of services just due to lack of connectivity into the specific customers, especially in rural America. Now, as explained before, the FCC has allocated the CBRS band especially to deal with this issue, especially to solve this issue of connectivity by creating a spectrum that deals with a lot of the shortcomings that other spectrums have. To start with, it creates the capabilities for the radio in order to deliver high-end services, a lot of spectrum, 150 megahertz, enabling high capacity, high bandwidth. It enables high transmit power up to 47 dBm and even more, which allows you to get to a longer range. This is compared to the traditional unlicensed 5 gigahertz band that supports only 36 or 30 dBm EIRP. Now, the combination of the wide spectrum together with the high EIRP at a lower frequency, the 3 gig, enables very good near line of sight type of performance, very good penetration through vegetation, and it allows to get to a longer distance in many, many cases. Commercially, the bottom line of those changes, of those bands, is that you can reduce significantly both the CAPEX and the OPEX. For the smaller amount of towers with less equipment, less base station, you can get more coverage, longer distance with high capacity. And this is because of the higher fixed power and the wider spectrum that is available. The increase in covered customers, higher capacity, and the significant decrease in tower requirements results in higher revenue. You can get more revenue while spending less money on infrastructure. Now, a little bit more on the CBRS spectrum, and then I'll touch on the different tiers. As shared before, CBRS basically creates three different tiers of service. The highest tier is the incumbent, mostly federal radios, federal radars, military radars. The next tier, which again is the high tier, is the incumbent wireless broadband service providers. Those are service providers that already got access to the band between 3.65 gig all the way to 3.7. Those are services that are available. Those are frequencies that are available today. The next tier is the PAL, Priority Access License. This is a licensed type of service. I'll touch in more details. I'll touch about it in more details in the next slide. And then the GAA. PAL, Priority Access License, is between 3.55 all the way to 3.65. And GAA is between 3.55 all the way to 3.7. It covers the entire 150 meg. Now, a little bit about PAL. PAL is a shared spectrum in total up to 70 meg in a given geographical area will be allocated to PAL, and this will be with a licensing fee based on the auction that will take place. The exact detail and cost of the licenses, the process of the auction are unknown yet, and this is something that the FCC with the industry forums are working on and are hoping to close in the next, probably the beginning of 2018. Now, each licensee, each specific service provider can get between 10 to 40, can get licensed for 10 to 40 of the total 70 megahertz. So you can see that you can have several licensees within a specific geographical area. Now, because of the frequency, the spectrum available, and the type of service that can be delivered, it is expected that the licensing fees will be higher, which means that in most cases for rural ISPs, this will not be an option. Although it's a good frequency, good spectrum, because of the licensing cost, we don't expect it to be affordable for rural ISPs. Now, GAA. GAA is a different story. GAA is something that is, as I explained before, covers the entire 150 megahertz. And out of the entire 150 megahertz, 80 megahertz will be allocated to GAA users in case PAL is allocated. So it is expected that GAA users can just find any type of available spectrum, and based on the SAS, which is the Spectrum Sharing Management Software, it's a server that manages all the users in any given geographical area, the customer can get any GAA capacity between 80 meg all the way down to 30 in case both PAL and incumbents are being deployed in the same area. So GAA can get all the 150 megahertz in case PAL is being used in the same area. The overall allocation goes down to 70 in case in the same area you get incumbent wireless providers. The overall spectrum allocated for GAA can be as little as 30. So overall, there is some type of variant in the GAA spectrum available that may change because of the overall conditions within the geographical area. So the service provider can start with a specific shared spectrum with 60 meg or 80 meg, and then as soon as the PAL licensee gets in, it can go down. So this spectrum, although it can be a wide spectrum, can change and breathe over time in resolution of hours, days, or months. So this is something that is expected to change. Now, an important point to note, and this is something that is mentioned in the FCC Part 96 standard, GAA users should not have any expectation of interference protection from other GAA users. So GAA user needs to give protection to higher hierarchies, it needs to give protection to PAL users, it needs to give protection to incumbent users. However, other GAA users may interfere a specific GAA user. So in that sense, the CBRS band for GAA users is more similar to unlicensed band than it is to licensed band. So this is a very important point to note while having the kind of the technical consideration of what type of solution is needed in this band. Now, the bottom line, the conclusion of what I just said is that the GAA band, although it has a lot of spectrum, may experience two fundamental issues. One of them is bandwidth fluctuation that is a result of changes in spectrum allocation due to additional PAL users or incumbent users. And in addition, it is subject operating at the GAA band, in the CBRS band as a GAA user is subject to interference from a GAA user. So those 2 points are important to note, and I'll address them in the next few slides. Now, in order to get very good capacity and effectively utilize the CBRS band as a GAA, those 2 problems that I shared before need to be addressed. So to start with, the first problem is interference. As I said before, the operating in the GAA, in the CBRS as GAA is subject to interference from adjacent GAA users. So you need to be able to deploy and utilize equipment that is able to use interference mitigation techniques. Beamforming is what I believe is the best option to deal with interference, manage interference, and operate with high performance under interference. So this is one very important element while operating in the CBRS as a GAA, under GAA license. Now, the other one, the bandwidth fluctuation. Given the fact that the bandwidth is expected to breathe in a way that is not predictable for a GAA user, we are proposing to utilize the 5 GHz as a complementary band. What it allows to do, an equipment that is able to use both CBRS and 5 gig simultaneously, can utilize 5 gig and the CBRS band simultaneously in the most efficient way. If CBRS is needed in order to reach longer distances, higher capacity, and the spectrum is available, the CBRS band will be utilized. However, if momentarily or for a short time the spectrum allocation changes, the 5 GHz, the traditional unlicensed band, can jump in, take over, and augment the capacity. So a platform that it can automatically self-manage without interference from the user can have a CBRS and 5 gig coexist and operate together to deliver high-end SLA type of service, gives a value and enable to optimize and maximize the value of the CBRS GAA band. Now let's talk a little bit about interference. As you know, in most cases, while operating wireless equipment in a point-to-multipoint with a sector type of deployment, the sector antenna is quite wide, and it does 2 things. It radiates in many directions simultaneously, adding to overall environmental noise generation, and at the same time it receives from all the directions at the same time, which again adds a lot of accumulated noise, and at the same time is subject to interference that comes from any direction within the sector. Beamforming technology considerably changes this approach. With beamforming technology, the base station, while communicate with a specific CPE, does it over a narrow width beam. So comparing to a 90 degrees typical sector antenna, beamforming antenna is able to communicate over something that is more on the order of magnitude of 10 degrees. So when a base station communicates with the CPE, it communicates over a 10 degrees beam. The difference is huge. It means that significantly less noise is being accumulated as part of the reception, less noise is being transmitted, and if there is an interference, a narrowband interference that comes in a specific direction, most likely it will not interfere, and if it interferes specific CPE. So the beamforming technology is a very good way to deal with interference, and this is especially critical for the CBRS band when an adjacent CBRS GAA user can transmit high power, as I stated before. Now, as I said before, and you can see it here, the GAA band, due to its nature, is breathing. You can see that over time you can start with 40 meg, go down to 10, and then jump back to 80. So when you have a lot of spectrum, it's very good because you can deliver high level of services to your end customers. However, every time the spectrum changes, you don't want your end customers, to see fluctuation in capacity. So what we are proposing, and we think is the best solution, is to augment the CBRS capacity with 5 gig unlicensed type of technology. What it does, it allows you to manage the two. So if there is a drop in CBRS spectrum allocation, you go from 40 to 10 megahertz, the 5 gig can augment. You can grab on the more spectrum in the unlicensed band, and overall deliver more capacity. So as you can see on the right-hand side, overall the base station can communicate with each one of the CPs, either at the CBRS band or the 5 gig band, making sure that the combined capacity delivered to the customer from both the 5 gig and the CBRS band is what the customer is expected to see and would like to see for the services that the customer is consuming. Now, what it enables us to do is something that significantly increases the efficiency of the sector. As you know, once you get closer to the sector edge, capacity decreases. Now, at CBRS, as I said earlier, due to the EIRP, you can go longer distances. And so the CBRS band is very good at getting longer distances with high level of with the high level of service, with high capacity. However, for customers that are close to the base station, you don't want to waste good resources that you can use at the sector edge to give service to customers that are very close to the base station. So the combination of a single sector that has both 5 gig and CBRS enable you in an efficient way to deliver services that optimizes efficiently the utilization of the sector. For users that are close to the base station, that are able to get good service over the unlicensed band, they will get it and without using and utilizing any CBRS resources. What it means is that you can use the most amount of CBRS resources in order to deliver services to customers that are further away. So as a result, you get better coverage at the sector edge. So the combination of 5 gig and the CBRS enables you to make the data delivery or service delivery within a sector more efficient, increasing the overall capacity of the sector significantly. Now, just to summarize, so the CBRS band with its wide spectrum, 150 megahertz, and the higher power, 47 and higher, depends on the bandwidth, it creates a unique opportunity for a rural service provider to improve their business model utilizing this band. Most likely, rural ISPs will not use PAL due to the licensing cost, rather use a GAA type of license, which is free of cost. The GAA bandwidth should be considered as unlicensed band rather than licensed band because of the challenges of interference from other GAA users, and it may experience both capacitive fluctuation and interference. Beamforming technology, because of the above, beamforming technology combined with air interface optimized interference management tool is critical for deployment in the CBRS band with a GAA type of license. And in order to deal with the capacity fluctuation, dual band CBRS and 5 gig equipment gives a great value to optimize and maximize the use of the CBRS band. Thank you very much, and we'll open the floor for questions now.
This is Bob, and I did see a question that I can tackle. It was asked, when do we predict the first SAS will get FCC operational approval, and similar estimated timeline for seeing the devices getting FCC authorization. Well, I had recently seen that the WIN Forum, I mentioned earlier, was the group that's handling the development of standards for the CBRS. They had forecasted both the first SAS approvals and the CBRS device certifications sometime by the end of this year. We haven't seen anything yet, but so that is a timeline that we can start looking for. And there were a couple of other, I think, technical questions. I don't know if Dave or Don wants to tackle those.
Can you hear me? Is it okay now? Yeah.
We can hear you, Don. It's still muffled, but we'll do our best.
Okay, so let me try to answer David Fritz's question. The question was about the EIRP, that any transmitter above 20, any EIRP system with EIRP higher than 23 dBi with a 23 dBm EIRP and higher requires approval from the SAS prior to transmitting. So this is there are two implications. As you wrote in the question, David, is that the implication is that almost any system with the external higher gain antenna is subject to the either Class A or Class B type of services. That means that it requires communicating with the SAS prior to transmitting. This is something that the wireless innovation forum is working on. The exact procedure is not defined yet. We expect it to be defined in the first half of next year as part of the second release of specifications for the SAS. Some of the ideas that are being considered is that the CBSD, the CPE, will be able to start transmit low power without getting approval from the SAS, and then slowly increasing the power until it's able, up to a certain limit, until it's able to communicate with the base station. Obviously, once it communicates with the base station, all the communication to the SAS, including the heartbeat, can be done via the base station. So although this is something that is not closed yet, it's being worked on. The industry is well aware of this challenge, and they are trying to sort it out. And what I said is one of the leading ideas of how to deal with it.
One question, this is Bob again, that I wanted to look at. Now, I'm not 100% sure of the answer, but someone asked about having acquired 3.65 company and wanted to maintain that, but move to towers that they own, and would that affect the grandfather status? I mean, the answer is it depends. We obviously don't know the locations of these towers and how everything is operating, but that is certainly a cautious way to approach it, in that it could affect the grandfather status. So that is something you do want to work closely with your engineers and regulatory counsel and FCC staff, just to make sure that if you are going to undergo any modifications, that doesn't actually change the parameters that have been afforded grandfather status. So that's a good issue to highlight there.
There is another question about who is allowed to operate Class A or B, whether it's PAL or GAA. So both PAL and GAA users are able to operate either Class B or Class A type of devices. As part of the installation process and then the access to the SAS, the server that allocates spectrum, you mentioned what type of what class of device you are and what license you had, and get allocation based on those two parameters.
Yeah, there was another comment, a good question, talking about the CBSDs require professional installation per the FCC rules, and when do we see the Wind Forum certification standards to be released and certified installers available for deployments? So I would first say I don't know that there's any way to affirmatively answer that question since the final rules have not been adopted and there's testing going on. But I do expect, my own personal opinion is that it's going to be delayed until some of these power issues and device issues get clarified through field studies and field engineering. So there's an opinion out there that the CBRS ban in general for adoption will be delayed through some of these petitions that are coming in. So it's logical to think that many of these potential decisions will be delayed until those petitions are acknowledged.
Thank you, Dave. That does conclude the conference call for today. Please visit ruralwireless.org, our webinar page next week, for access to this recording, and the slides will be with it as well. We thank you for your participation and ask that you please disconnect your line. Thank you.